We recall the problem of the circle inscribed in the first quadrant of the big circle, and we're trying to figure out what the radius of the little circle is. And we did some really good stuff here, but I discovered a flaw in what we did. The flaw is this. In solving the system, we got, you did a really good job. I did a pretty good job, but Bonehead here screwed up. We assumed that this side of this triangle here was equal to the diameter of the circle. Okay, this blue triangle, we assumed this diameter was equal, or this side was equal to the diameter of the circle. Now, this triangle is supposed to go from here to the big circle, and of course to the point where the little circle meets the big circle, and there are symmetry arguments that show how that should occur, and show that this does occur at a 45-degree angle. If we draw the picture really carefully, we see pretty clearly that that's not the case, that this distance here is not equal to the diameter of the circle, because if we go up here where the two circles meet and project straight down, they don't meet at the point that's furthest to the right on the little circle. They meet back this way a little bit, and this line cuts across the little circle. So this is not equal to the diameter of the little circle. So, taking this triangle here with the smaller triangle embedded in it, this side is not double the radius of the small circle, and that was the premise for this solution. Now again, this is a great solution for that premise, but the premise is no good. Not quite right. So what are we going to do to fix it? Well, I have a few ideas. Let's assume that we can get the symmetry argument down straight. We pretty much have that. But you might think a little more deeply about the symmetry argument if you're so inclined. But I think I see where that is. Let's draw the same triangle down here again and label the various points A, B, C, the vertices of the big triangle, and then D, E, the vertices of the smaller triangle. That's, of course, similar to the bigger triangle, and we both see that real easily. DE is just this, and this is just the radius of the little circle. So we know that DE is the radius of the small circle. We know that AB is not 2R. That was our original premise, but it's not so. What else do we know? Now, I'm thinking that the answer to these questions here and the other questions, and all I'm indicating here is, do we know this distance AD? Do we know this distance AC? Do we know AE? Do we know AB? Do we know those distances? Do we know BC? Do we know DC? Do we know EB? Which of those distances do we know most obviously in terms of the parameters, parameters of the bigger picture? Okay, radius of the big circle is R, and so forth. So one of these is really obvious. Another one is really important. So I say two of these actually are pretty obvious, to be obvious. Okay, the rest be following fairly easily. Can you figure out which one is which one is obvious, and how the rest follow pretty easily once you know that one? I say pretty easily. There's still work to do, but it's, I think, pretty manageable. So see what you think. See if we can fix this and become famous.